Your SSD is faster than a hard drive in almost every way. But it's also doing something a hard drive never had to, quietly counting down. Every solid-state drive is built from a kind of memory that can only be written to a limited number of times, an actual number, ticking down, cell by cell, every time you save a file. So how does a drive with a built-in expiration date manage to last for years? The answer is a small, constant, hidden effort happening every single time you write anything at all. Inside an SSD, each bit is stored in something called a floating gate cell, a tiny transistor with an extra piece added to it, a small conductor sitting completely surrounded by insulation, buried inside the transistor itself. To store a 1 or a 0, the drive pushes a group of electrons onto that floating gate, using a strong enough electrical push to force them straight through the insulation around it, a process that normally would never happen at normal voltages. Once those electrons are sitting on the gate, the insulation traps them there, no power needed to hold them in place. That trapped charge changes how the transistor behaves, and reading the cell later is just a matter of checking for that difference. That's the whole reason flash memory doesn't need constant power to remember something, unlike the RAM your computer forgets the instant it loses power. The charge is physically stuck in place. Here's the problem. Forcing electrons through an insulator isn't free. That insulating layer is only a few atoms thick, and every time it happens, writing the cell and later erasing it to write something new, it stresses that layer a little more. Do that enough times to the same cell, and the insulation stops doing its job properly. Electrons start leaking through on their own, or the cell can no longer reliably hold a clean charge at all. At that point, the cell is worn out, not broken like a snapped wire, just no longer trustworthy. That enough times isn't the same number for every drive. A cell built to store just one bit only ever has to tell two charge levels apart, mostly empty or mostly full, which leaves a wide margin of safety as the insulation ages. The cell built to squeeze in 4 bits at once has to tell 16 different charge levels apart in that same tiny space, with almost no margin left. That's the real difference between a cheaper, higher capacity drive and a more expensive one. Not a shortcut in how it's built, but a direct trade between how much one cell can hold and how many times it can be safely rewritten. Every SSD is built from millions of these cells, and whichever version it uses, that cell's lifespan is fixed the moment the drive is manufactured. No firmware update can change that number. A drive can only slow down how fast it gets there. If wear alone told the whole story, drives would die within months of repeatedly hitting the same file updates. Things like a system log, a database, or a swap file. They don't, because of two things working together underneath everything you do. The first is an asymmetry most people never hear about. An SSD can flip individual small sections, called pages, from a 1 to a 0 whenever it writes. But it can only reset things back to 1, erasing, across a much bigger chunk called a block, made up of many pages at once. You can't cleanly erase just one page. Changing a single page you've already written usually means copying every other still needed page in that block somewhere else first, erasing the whole block and rewriting it. That means the drive frequently ends up physically writing far more data than you actually asked it to save, a cost called write amplification. The second is wear leveling. The drive keeps an internal map between the address your computer thinks it's writing to and the actual physical cell it uses. Instead of hammering the same physical cells every time you save the same file, the controller spreads writes across the whole drive, cell by cell, so no single spot wears out while the rest sit untouched. Your computer has no idea this is happening. As far as it's concerned, it's just writing to the same file in the same place every time. There's one more piece, and it starts the moment you delete something. When you delete a file, your operating system just marks that space as free. It doesn't erase anything itself, and for years it never told the drive either. The drive kept treating that space as still full of real data, unable to reuse it efficiently. The fix is a command called trim. It lets the operating system tell the drive, directly, this data is gone, you're free to erase it whenever it's convenient. That gives the drive room to do its erasing quietly in the background, ahead of time, instead of being forced into it at the exact moment you need to save something new. Wear leveling spreads the damage evenly. Trim gives the drive room to manage it efficiently. Neither one stops the wear. Both exist to make sure you never notice it happening for as long as possible. An SSD isn't lying to you when it feels instant. It's just quietly spending down a resource it was built with a fixed amount of, and doing everything it can to spread that cost evenly across every cell it owns. So when a drive does eventually fail after years of heavy use, it isn't bad luck, and it isn't a defect. It's a physical medium finally reaching the one number it always had from the very first day you used it.